If y is equal to f of x, which is equal to e to the power of ax, then dy by dx will be a times e power ax. In order to prove this, we'll be using the definition of derivative, which is dy by dx equal to limit h tends to 0, f of x plus h minus f of x divided by h. So here dy by dx will become now limit h tends to 0. And instead of f of x plus h, we will be writing it as e to the power of a times x plus h minus e power ax divided by h. Now the numerator can be further simplified as limit h tends to 0, e to the power of ax into e to the power of ah minus e to the power of ax divided by h. Now we can take this e power ax outside the limit because it do not have any h in it. So we can take e power ax times limit h tends to 0. Then inside the bracket, we can write it as e power ah minus 1 divided by h. Now, let us assume this ah as t, which means if h tends to 0, then t also will tend to 0. And further, we can write h as t divided by a. So this limit can be now, this e power ax will be e power ax only. This limit now, instead of h, we will be bringing in t now. Limit t tends to 0 and e to the power of t minus 1 divided by t by a. Now this can be further simplified as e power ax limit t tends to 0, and we can bring this denominators a, I mean denominator it is t by a, that a will go to the numerator. Since a is a constant, we can take it outside the limit. So I can bring that a this side and I can write this as e power t minus 1 by t. Now this is nothing but 1 based on the useful limit. So we can express this as a times e power ax times 1, which is nothing but a e power ax. That is the proof.